everyone, I'm Chung Ya Ying. Today I'm going to talk about linear independence of vectors. In this tutorial, I'm going to introduce and define linear independence of vectors. Next, using the concept of vector span and determinant to test whether a set of vectors is linearly independent. Then I will give some examples and exercise for you. First of all, a set of vectors is linearly independent if no vector in the set is a scalar multiple of another vector in the set, or no vector in the set is linear combination of other vectors in the set. By the definition, the vectors in a set are said to be linearly independent if the following equation can only be satisfied by ai is equal to 0, for I is an integer from 1 to n. Now, before using vector span to test whether a set of vectors is linearly independent, you may ask, what is vector span? Vector span is the intersection of all subspaces containing the set, and you can simply think it is how many dimensions the set reach. The geometric meaning of linearly independent vectors is no waste direction in the span. Every vector gives new dimension. So, deleting any vector may produce smaller span. We can just simply plot the vectors on a graph. Two vectors are always linearly dependent if they are collinear. We can see that each vector in blue area doesn't give new dimension to the set. So, the span of the set containing that two blue vectors is only the line they lie on. However, the set containing these two vectors in red area has a bigger span equal to R2, which is a two-dimension span. These two vectors enlarge the span of the set, so they are linearly independent. The same reason for three vectors. If they are coplanar, then they are linearly dependent, and vice versa. There are special cases that if the vectors in the set are perpendicular to each other, the set of vectors are always linearly independent. For instance, vector A and vector B are two perpendicular vectors. No matter how to scale the vectors up, the zero in the vectors are always going to be 0. Vector B can never be represented by a scalar multiple of vector A. Therefore, the set containing two perpendicular vectors is linearly independent. It is also why a set containing three vectors that perpendicular to each other are always linearly independent. After using vector span, we are going to use determinant to find whether a set of vectors is linearly independent. Two vectors are linearly independent if the matrix combining these two vectors like this has a non-zero determinant. Here simply shows you how to calculate determinant of a 2 times 2 or 3 times 3 matrix. Now, let's look at some examples. Whether vector A, B, or C are linearly dependent or independent to each other, we can see that vectors A and B are linearly independent, because they are not the scalar multiple of each other. Also, C is equal to A plus B. Vector C is a linear combination of vectors A and B. So, the set of vectors A and B and C is linearly dependent. Here is example 2. Obviously, vectors D, E, and F are linearly independent, because no vector in the set can be represented by a scalar multiple or a linear combination of any other vectors in the set. Example 3. Whether these three vectors are linearly dependent or independent. We can calculate the determinant of the matrix combining these three vectors. It is 0, so these three vectors are linearly dependent. Two exercises for you to practice. Exercise 1. Whether vector G, H, I, and J are linearly dependent or independent to each other. 2 minutes starts now. In exercise 2, whether these three vectors are linearly dependent or independent. 2 minutes starts now. That's the end of my tutorial of linear independence. Thank you.